Hello, Honors Algebra students. Here is your Chapter 7 review. Remember, we're going to take the test on Wednesday. We're going to start with direct variation. Remember that if x and y vary directly, we can use an equation like, hold on a second, like y equals kx. Sorry about that, I'm in the wrong kind of pen there. There we go. Let me write that y equals kx. K is the constant of variation, and that's just like the slope. And so when I have an equation, or I have that x equals 6 when y equals 10, I'm going to take y equals kx, and I'm going to put 10 in for y, and k I'm solving for. I put 6 there. I'll divide by 6, and so k is going to end up equaling, what's that going to be, 1 2/3, I'm thinking. Okay, now I'm told that x is 10, so I'm going to find y. I'm going to take 1 2/3. I'm going to multiply that by 10. Now, I know that 1 2/3 is the same as 1.6 repeating. Well, if I multiply that by 10, I would think I'm going to get point like that. So y is then going to equal 16 2/3. Now, if I wanted an equation of the constant of variation, it would be y equals 1 2/3 x. Or if you wanted to, you could have gone with 5/3. Okay, y equals 5/3 x instead of the mixed number, because we usually don't do a mixed number for a slope. But anyway you look at it, there it is. There's your y, and there's your equation. All right, then we solve some systems. And so let's solve this system by graphing. And I'll do the blue equation first. Y-intercept of -4. Looks like the slope is going to be 1 over 1. And so I shall draw okay. Get my line graphed. Sorry for the delay there. Okay. Now I need a red line. Okay. And I'm going to find the y-intercept of +4. 1 2 3 4. Okay, and the slope is going to be -1/3. So I'm going to go down 1 2 3, down 1 1 2 3, and look at that, they're crossing right there. So I'll get my line drawn. I'll go up 1 1 2 3, and get them to cross. And they're, like I said, they're crossing right here. So the solution looks like it's at 1 2 3 4 5 6 1 2. So the solution to this system is 6 2. Solving by graphing. Okay, solving by substitution. I'm going to take this top equation here, and I'm going to solve for x. And I know that x is going to equal 1 minus 2y. I'm going to rewrite the second equation. Wherever I see an x, I'm going to plug in the 1 minus 2y. Okay, minus 8y equals -1. I'll distribute, and I'll get 2 minus 4y minus 8y. I'm going to combine these like terms here. We'll get 2 minus 12y, and that'll equal negative 1. Subtract 2 from both sides, and I'm going to get negative 12y, negative 3. Looks like y is going to equal positive 1/4. And then to figure out x, I'm going to take that and I'm going to plug it in right there. So change my color here and go x equals 1 minus 2 over 1 times 1/4. That's going to turn into 1/2. So we have 1 minus 1/2. So x is going to equal 1/2. So the lines would cross at the point 1/2 of 1/4, which would be difficult to determine if we do by graphing. All right, now to solve by elimination, I'm going to try to get either the coefficients on x to match with opposite sides or on y with opposite sides. Now I always want to do the one with the least amount of work, and I notice that 5 is half a 10, so if I multiply this top equation by negative 2, that will turn that equation into a negative 10x minus 14y, that will equal negative 8. And when I do that, those are going to cancel. I'm going to get a negative 16y, and that'll equal negative 10. Divide by negative 16, and then y is going to equal 5/8. All right, now I'm going to take that 5/8, I'm going to plug it into one of the original equations. I think I'm going to plug it into this one here because there's a 2. And then I'm going to solve for x. So I'm going to get 10x minus 2 over 1 times 5 over 8. And that's going to equal negative 2. And I'm going to simplify. And so I'm going to have 10x minus 5/4. But I'm going to think about it as 1 and 1/4 equals negative 2. Now I'm going to add 1 and 1/4 to both sides, right? And this should start to get easier for you if you're not always depending on your calculator. If I have $2 minus $1.25, I have 75 cents left. But since the 2 is negative and the $1.25 is positive, it'll be a negative 3/4. Or you could, better yet, since I've got a 10x there, I might even think about it as a negative 0.75. I'm going to divide by 10, and divide by 10, and I'm going to get x is going to equal negative 0.075. Very unusual answer here. I guess I could do the 3/4. Divide by 10, we could say is multiply by 1/10. So that'll be 3/40. And this must be 3/40 simplified. It'll be negative. So the place where they cross, we had negative 3/40, comma 5/8. And I don't know why I said the comma. I guess I've been teaching 8th graders too long. But there you go. All right, remember there's consistent, inconsistent, dependent, independent systems. All right, so let's look at this red one here. And in the red one, I notice that they have the same slope. There we go. I notice that the two lines have the same slope, which means the lines are parallel, which means they're not going to cross. That makes them inconsistent. Okay. Now, on the second one thing I noticed is the top equation is 1/3 of the bottom equation. For example, if I multiplied by 3, this would turn into 6x minus 12y equals 3. They would be the same equation if I multiplied the top one by 3. So in effect, they are the same equation, which means they're going to intersect everywhere. So this is a consistent system because there is a solution, and it's dependent because the two lines are going to intersect each other everywhere. Okay, finally, this last one, I noticed the slopes are different, so these two lines are going to intersect. They have different y-intercepts, therefore they must be different lines. This is a consistent, independent system. All right. Okay, let's do a couple story problems here. How many ounces of a 25% acid solution should be mixed with a 50% acid solution to produce 100 ounces of a 40% acid solution? Well, I'm going to let X equal the ounces, 25% solution. Y is going to equal the ounces of the 50% solution. And so my first equation is going to be X plus Y, and that's going to equal 100. Now my second equation is going to be 0.25x plus 0.50y, and that is going to equal 0.40 times 100, and that's the same as 40. So I'd like to do it by substitution. I'm going to say that y is going to be 100 minus x. So I'm going to go 0.25x plus 0.5 times 100 minus x, and that's going to equal 40. 0.25x plus 50 minus 0.50x equals 40. I'm going to combine my like terms, which are, where'd they go? My like terms are here and here, but then I'm also going to subtract 50 at the same time. And when I do that, I'm going to end up with a negative 0.25x equal negative 10. And then divide by negative 0.25, and that's going to be the same as x is going to equal 40 ounces. Now if x is 40, then y must be 60, so y is going to equal 60 ounces. And there you go. Pretty simple stuff. All right. Let's try this one. Sam has a total of 43 coins consisting of nickels and quarters. I've got my first equation already. I know that n plus q is going to equal 43. Now, how much money do I have? Well, from the nickels, I have 0.05n. From the quarters, I have 0.25q, and then that's going to equal $7.75. I'm going to do this by substitution, I think, and I'm going to get that n is going to equal 43 minus q. So I'm going to do 0.05 times the quantity of 43 minus q plus 0.25 q, and that'll equal 7.75. I'm going to distribute here, and I'm going to negative 0.05 q plus 0.25 q, 7.75, and I'm thinking 10% of this is 4.3, right? And half of 4.3, half of 40, well, half of 42 would be 21, right? So I'm thinking it's going to be 2.15. Yeah. So this should be 2.15. But let me just double check that. Yeah, I like that answer a lot. Again, I've got like terms here. Oops, not there. I've got some like terms here. I'll put those together, and I'm also going to subtract a 2.15, $2.15 from both sides. So what that will give me will be 0.20 Q, which, by the way, I'm thinking in my mind that's 1/5, and that's going to be 5.6. All right, and so I'm going to divide by 0.2, divide by 0.2, so 5.6, divided by 0.2, do my little caret thing, and I'm thinking that that's going to be 28. So that must mean there are 28 quarters. Okay, there's 43 total, so 43 minus 28 looks like it's going to be 15. So there must be 15 nickels. Now I can check myself. Quarters are 25 cents a piece, so 28 times 25 cents, well, that would be $7, right? Now 15 nickels, and each nickel is 5 cents, so that looks like it's going to be 75 cents. And 75 cents and $7 is $7.75. Silly. All right. Last problem for this review. We're going to use standard form to graph here. And I know when x is 0, y is going to be -3. So I go 1, 2, 3. And it looks like my slope is going to be 2. So I'm going to do something like this. Now it's going to be a broken line because it's not equal to. So like that. All right. And I'm going to shade that in blue. I put 0 less than 3. Yeah, 0 is less than 3, so I'm going to shade this part of the graph. Okay. Now, for the yellow one, looks like I'd like to add 2 to both sides. So I'm going to get 2y is less than 6x plus 2. And I'm going to divide by 2 all the way through, and I'm going to get y is less than or equal to 3x plus 1. So it's going to be a y-intercept of 1. I'm going to 1, 2, 3, 1. 1, 2, 3, 1. And 1, 2, 3, 1. And 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And before I actually draw my line, there we go. I wanted to get them to where they finally intersected. Looks like my line's going to be solid because it is equal to. And so it's going to do this. Okay, and now where am I going to shade for this black one? Well, I can plug 0 less than or equal to 0 plus 1, and it looks like 0 is less than 1, and so that is a true statement. So I'm going to shade towards the origin, and that's going to go like that. And there we go. You can see that the solution area is this wedge up here that's got the green in it. Okay, and technically it would come all the way to this dashed one, but it's in that region there. All right, that's your review video. Hope it wasn't too boring. Good luck on your test. Miss Lawrence signing off.